Hello everyone. Today I'm going to explain about the deadlock in Java. As we know, while we are working in thread environment like multi-thread environment, then we may face this kind of situation where this kind of deadlock kind of situation is occurred. So how we are going to analyze those log, how you are going to detect that deadlock can occur, how you're going to debug, those things I'm going to explain over here. And also how how you're going to write programs so that deadlock can never happen. So there are certain points that also I will explain over here. So let's say there is a two thread 1 and thread 2. So this is basically thread how this deadlock situation basically occurred. So deadlock in Java basically it's part of the multi-threading. Deadlock can occur in a situations when is any thread is basically waiting for object is locked and that is acquired by another thread, that is second thread, and this second thread is also waiting for lock that is acquired by the first thread. Okay, like thread 1. So as since these both threads are waiting for each other to release the lock, then this kind of situation occur. This is called the deadlock. So here basically I'm going to explain how we can replicate the deadlock kind of situation using writing the program, so that we can understand how we are going to avoid those kind of things, and also how we can write a program so that we can simulate the same deadlock situation, and also how can we detect the deadlock in a real applications program. There are certain ways that using that we can detect the deadlock, that I will show you one of the options for this, and also how to avoid the deadlock. Okay, so there are certain points we need to avoid the nested locks, then lock only when it is required, and avoid waiting indefinitely. So these 3-4 points, bullet points over there, that if we avoid, then deadlock occurring of the deadlock chances are down. Okay, so let's write one program to simulate the deadlock, so that we can understand, and also we will analyzing log so that we can understand in detail about the deadlock. So deadlock in Java programming basically is situation where two or more threads are blocked forever. So Java deadlock situation basically arises when at least two threads are and two or more resources over there. Okay. So here I will write one Java program to simulate the deadlock in our application actually, so that we can replicate the same things. So I have already created one Java project over here, and here I have created one package basic thread. Here let me create one class. Okay, so let me deadlock in Java. Okay, so here first of all we can try in one main method over here, because in Java class main is the entry point. This is the main thread actually. Okay, so here we can create three object equals to new object. Okay, similarly we can create another two object over here, object 2 and object 3. Okay, next we can create thread t1 equals to new thread. Here basically we can create one custom thread, and it will take two parameters. So let me create this custom thread. Here you can create another class custom thread. It will implement, because whenever we are creating any thread, so thread can be created in two ways, either implementing the runnable interface, or by extended thread class. So when actually we are implementing a runnable thread, then it is actually one method that we need to implement, that is called the run method. So that's actually this method actually we need to override. Okay, and here we can define these two object, private object obj1 private object obj2. Okay, now as you can see over here, we need to pass these two object over here. So I need to create one constructor over here, this constructor, and it will take two object, or I can say we can pass this one and then this one. We are initializing the object over here. This dot object1 equals to obj1, this dot obj2 equals to obj2. Okay, so we have initialized this one. Now here basically we need to pass this one, okay, while creating this thread object1 object2. Okay, in similar fashion we will create another thread t2, and here we will pass object2 and object3. Again we will create another thread t3, and here we will pass object3 and object1, object3 and object1. So here also we can pass the thread name like t1. Here also we can pass the thread name t2, and here we can also pass the thread name t3. Okay, now so inside of this run method we can print the thread name, and also we can lock our object so that we can simulate the deadlock situation. So how we are going to fetch the thread name? So thread class, using the thread class actually we can get the current thread, and over here we can get the name. Okay, so how we are getting the name? So thread class having the from this is the current thread actually, and this from current thread actually there is one method name, that is the get name. Using this get name we can easily get the name of the current thread. Okay, now after this we can print the name of this thread. So we can say we are, or maybe this thread plus name, this thread acquiring lock on this object1. Okay, now here after this we can use the synchronized block. As you know, this synchronized block basically used to for thread safety kind of thing. So here we can pass this object1. Now here we can we can print some name, or we can also print some log over here, and also we can put some sleep over here so that we can simulate. Okay, we can again print the name over here, similar log like thread, this thread acquiring log on this object1, and here after that we can put some thread dot sleep, and here we can put some sleep like maybe 20,000 or maybe 10,000, means 20 millisecond basically. Okay, this we can print. Okay, we need to okay, and after that, so this is for actually we are acquiring the log for this object1. In similar way we can create another synchronized block, that is for object2. Here we can pass this object2. Okay, so in this way basically we can like we can what we do means we can did the synchronized block over here, and over there we have print some put some sleeve over here for particular thread. Okay, if we little want to understand about this synchronized block, so whenever we are writing any code inside of this synchronized block, so that means it is used to prevent a multiple thread from executing this particular portion. Means it is kind of blocking kind of thing, means it is blocking. That means multiple thread it's not able to access on a single time. So that is why this synchronized block is used. It is basically kind of used for in a multi-thread if we are doing some locking kind of thing, or maybe if we want to not want to duplicate kind of work, so each thread can work in a single time, then we are using the synchronized block. Okay, so this is the basic funda of this synchronized block. So here basically this thread here we can write like finish execution. Okay, execution completed, execution completed. Okay, so here this custom thread basically implementing this runnable interface, and it work on these two objects by according this lock on each one of them by using this synchronized block. Okay, in main method we are calling this three threads running this custom thread, and these three are shared resources between each of these thread. The threads are run in such a way that it will be able to acquire lock on the first object, but when it is trying to acquire the lock on the second object, it goes on the wasted because it's already locked by another thread, right? So this is a kind of the cyclic dependencies between resources, so threads becoming the deadlock. So now actually we will execute this example, but before executing this we need to start the thread. So how you are going to start the thread, like t1 dot start, and after that also we can like we can put some thread sleeve over here for maybe 5 millisecond, let's say. After this one this, or we can from here we can throw the interpreter exception. Okay, so t1 start, then t2 start, then t3 start. Okay, so here it will be a t2 and then it will be a t3. So we have started all this one is not required. Okay, so now this is done application wise. Now if we run this one, so it will print something this kind of thing in the log, and we can see the deadlock is happening. Okay, if we run this application over here, you can see this thread 1 acquiring log of this object, thread t1 is acquiring lock on this object, t2 t3 similar type of this locking is going on. Now like as this is a very simple actually applications, we have write this one, but in real applications whenever actually we are going to real life applications, so it is very hard to detect the deadlock situation and debug them, because how we are going to debug this one. So for detecting this one, there are actually certain ways to detect the deadlock and like to debugging those things and find out the situation like how it is happening. So for that we need to take out the thread dump of the applications. Okay, so for taking the thread dump from this Java application, so there are one options using the JStack utility functions that Java is provided already. So using this we can get this using the thread dump. So how we are going to do this one? If you are working on the like Linux application, then it is very easy, because using the there's the Unix command like Java grep Java, then using this you can get the PID of these applications, Java applications. But if you are on Windows, then from the task manager you need to get the like PID of this particular Java application. Okay, let me show you. Okay, so actually for me the ID was this, so that's why this JStack, and then using this we can get the thread dump of this of my thread dump over here for my application. So here you can see it's giving the details about it. So this is the thread dump of my applications. Whenever I run this one, then it's showing this is the thread state is waiting on this object monitor, that means it's not able to actually all the details. Its time is waiting, thread time waiting. So here actually all the things, the priority of this one, it shows all the things. Okay, thread name. So from here we can like debug these things. Like here it's 52, it's blocked. Okay, it's time waiting. So all the details from this like we can get the details from over here. Okay, so it's showing the things of how we are going to clearly shows actually the deadlock situation and threads are resources involved causing this deadlock situation. Like we need to look out this thread and state as blocked, and then resources is waiting to lock. Like this kind of things we can get from this thread dump. So every resource also having this unique ID, and like we can find thread is already holding the lock, and right. So these are the like IDs and all the thread IDs. Okay, these are the things waiting on condition, waiting on entry. So these are the things basically we can get details from over here, T1, T2, T3, right? So these are the thread name basically, T1, T2 and T3, and also like these are the priority and all. Okay, so now the thing is that when any program is situation, this kind of deadlock situation is basically occur, then how to avoid deadlock in Java. So there are some guidelines that actually you need to follow to avoid the deadlock situation. One is the like avoid the like nested locks. Okay, so as we have done over here, like nested lock, so that actually we should avoid. Like as I did, means if I did instead of over here, if I write the log something here, if I run this application, so it's basically locking the things, but instead of that we need to write in this way. Okay, so that it will not lock all the things. Okay, means we need to write in this way. This is the one of the things, means we should avoid the nested locks. Okay, this is the common reason for deadlock. Avoid locking another resources if it's already hold another one, so it is basically impossible to get the deadlock situation, right? Means we need to avoid the unnecessary locking. If it is required, then only we need to do the lock. And if deadlock of two threads are waiting for each other to finish indefinitely using that, then maybe we can use a thread join. So as to wait, if our thread basically is to wait for another thread to finish, then it's always best to use a join with the maximum time that we want to wait for finish. So that's all basically about this thread and all. Okay, about this deadlock. And if you guys have anything, please do let me know in the comment section. Thank you for your time. Bye bye.